Welcome back to part 2 of density, which carries straight on from part 1, part of the same lesson. So at the end of part 1 we looked at how to find the density of a regular shaped object. They are objects where you can easily find the volume of them, for example cubes, cuboids, cylinders, spheres, cones, etc. And I hope you've had a chance to watch the YouTube video that shows the practical of this. Moving on then. Before we do so, I'm going to leave it on the board, on the screen. If you want to take a note of any of this, please do so by all means. This is a required practical, so it's one of the ones that can be examined. Next, we're going to look at how to find the volume and density of irregular shaped objects. So irregular objects are those where we cannot easily find their volume. For example, a piece of rock or a statue, or something where the sides don't allow us to measure the volume accurately and easily. In this scenario, we have to use the following idea. Imagine a cylinder with some water inside it. We know the volume of the water because it's marked on the side of the cylinder. What would happen to the amount of, or the volume of the water, if we placed an object inside of it? Think about a bathtub. If something is put inside a bathtub, what happens to the water level? Well, the water level rises. And how much does it rise by? You might not know this, but the water level, the volume of water, increases by the same amount as the volume of the object that's been put inside it. So in this scenario, if we put a cube inside the water level rises by the same volume as the volume of the cube. And we can use this idea to find the volume of irregular shaped objects. So pretend that's not a cube, pretend it's a lump of rock or a statue. The volume of the water that increases with the volume of the statue. Then to find density, we just need to find the mass of the object, and we can say density equals mass divided by the volume of the object. And here is that practical. In this scenario, rather than just using a measuring cylinder, we'll be using something called displacement cans. And they are metal cans with a little spout on the side of them, out of which water can come out. The apparatus is listed on the side there. Again, we'll need digital scales to find the mass, and we'll need a measuring cylinder to find the volume. Measure and record the mass using the scales. You then set up a displacement can on a tripod. The reason it's higher up is so that we can place a measuring cylinder below it to allow the water to flow into when the water level rises once we place something inside it. Initially though, you'd fill the volume of the water higher than a spout, and in place of the measuring cylinder you'd have a beaker which collects the excess water. The water will then eventually stop dripping out of the displacement can. At that point you've got the water level just below the start of the spout. And that's where we want it. Step 3. Replace the beaker with the measuring cylinder into which you will collect the water. The irregular object will be tied to a piece of string and very carefully lowered in the displacement can so it's completely underwater. You won't just throw it in the displacement can because that might slosh water out. And the reason we have a string in there is so we can easily retrieve the object back out again. Remember, the string might, but it's negligible, which means it's very unlikely to increase the volume. Water will displace out, collect the water that comes out into the measuring cylinder, record the volume of the water that's been displaced, and this is equal to the volume of the object. And then simply, density equals mass of the object divided by the volume of the object. And again, there's a link to a YouTube video showing this scenario. I'm going to ask you to pause the video and make notes on this. This is still part of the required practical, so it is something that can be examined in the exam. And finally, looking at density of liquids. This is slightly easier, simply because we've got a measuring cylinder and inside which we have liquid, so we can easily find the volume and the mass, and this is how we do it. Again, we need scales. Remember, scales are always used to find the mass of an object. measuring cylinder, because we're looking at measuring the volume of a liquid. Place an empty measuring cylinder on the balance scale. You would measure and record the mass of the empty cylinder. You would then pour your amount of liquid that you want to, in this case I've chosen 50 mils, into the measuring cylinder, and you would record the volume of the liquid. You will then, on the scale, read a larger number than before, because now you're finding the mass of the cylinder, which was initially empty, plus the mass of the liquid, both together. How do you find the mass of the liquid? Simple maths. Total mass, take away the mass of the cylinder, equals mass of the liquid that's left. Calculate density using density equals mass divided by volume. There's a YouTube video link there for the video for this experiment. One thing I would like to point out is the video uses something called a tare method, tare spelled T-A-R-E, which basically means you would place the empty cylinder on the scale and then press the T-A-R-E, tare button, to zero it. It's another word for saying zero the scale. So that makes the liquid mass that you pour in the mass of the liquid alone. Something to bear in mind there. So these are the three required practicals. Density of a regular object, where you can easily use a ruler to find the sides and the radius and whatnot, find the volume. Density of an irregular object, where you can't easily find the volume using the dimensions. And the density of a liquid. And you'll notice all three of them require us to find the mass of the object, find the volume of the object, find the density using mass divided by volume. I'll ask you to pause the video there and make notes on that if you need to. And here's a reminder of the density, mass and volume. Have a go at questions 1 through to 9. I'd ask you to pause the video, spend about 10 minutes doing this. Please do show all your calculations. So if you do look back at this, and when you do look back at this for revision, you'll remember exactly how you found the answers. Pause the video and we'll go through the answers next. These are the answers you should have got. Just a reminder, numbers 1, 6, and 8 talk about grams per centimeter cubed. Remember, grams per centimeter cubed is the same ratio as kilograms per meter cubed, therefore we can use them as such. We could not use an interchange kilograms per centimeter cubed. That would be a different scenario altogether. So check your answers, see if they're correct. Please do correct any mistakes you've made before we move on. So here's a question. I've got two objects, two cuboids. One is a brick and one is a piece of foam. They're both the same volume. If I place them both in water, the brick would sink and the foam would float. Why? A common answer here is because the brick is heavier. You're right, the brick does have more mass, therefore is considered to be heavier. But that's not the main reason. The reason is the density. If the density of the object is more than the density of water, or whatever liquid we're putting it into, then the object will sink. If the density of the object is less than the density of water, the object will float. So it's all about the density of the object compared to the density of the liquid that we're placing it in. More dense object compared to the liquid sinks, less dense object compared to the liquid floats. And if you think about a float, if you go swimming and you try to push the float down, you'll notice there's a force pushing it back up again. That force in water is called upthrust. Pause the video and please make notes on this. And to end with, I'd like you to have a go at this exam style question based on the practical. Please do read it very carefully and answer. It's a 6-mark question, so try to answer the best you can. Think about everything we've talked about, and in this scenario, think about how you would use the information that's in this question to find the answer about use the data to find the density of oil. pause the video, 6 marks, give yourself 6 minutes, off you go. And this is what you should have got. 6 marks, how they're awarded. First, we need to find the mass of the measuring cylinder. And we can see from this diagram, at the top, we've got the mass of an empty measuring cylinder. The balance scale is reading 112 grams. We get 1 mark for stating that. You'll notice then, from the second diagram, we now have a measuring cylinder with some liquid in it, oil in it. The mass has increased on the balance scale. We would get 1 mark for saying the mass of the cylinder plus the liquid is now 172 grams. Your third mark, I'm going to skip one out here, but third mark would then come from, therefore mass of liquid is 112, take away, my mistake, 172, take away 112 to get the mass of the liquid without the mass of the cylinder, and that gives us 60 grams, that's 1 mark. We can see from the diagram that's zoomed in that the liquid is at 75 milliliters, which is the same as 75 centimeters cubed. Third mark there. If you look carefully, you'll notice that it goes up in 2s, 2, 4, 6, 8, 10, so 72, 74, 76. The liquid is between 74 and 76, so it's at 75. And we should always measure the liquid of inside any cylinder or beaker at something called the meniscus, which is where the liquid curves downwards. We want to measure at this point here, not at the higher point here. So it's 75. Finally, almost finally, density equals mass divided by the volume. The mass of the liquid is 60, volume is 75, and that gives us an answer of 0.8 grams per centimeter cubed. That's the end of the video. By the end of this video, we've looked at the facts in the fact book about density, about the idea that different states of matter have different densities, solids being the most dense, gases being the least dense. We've talked about how to find the density in regular, irregular, and liquid objects. We've talked about the idea of why some things float and some things sink. And we've had a go at some exam-style question. Thank you very much. I look forward to talking to you about lesson number 3 next time. All the best. Take care. Bye-bye.